Way 73 deals with chemical reactions, specifically the speed of chemical reactions. In order for a reaction to occur, it requires effective collisions between the reacting species. And what must happen is that you need the proper energy and orientation. Consider two molecules that are colliding. In order for them to react, they have to hit with the right amount of energy in the right orientation. If they don't do that, you're never going to have a reaction. Only when the energy is the correct amount will the species get activated and react to form a product. So anything that increases the number of collisions, such as increasing the temperature, is going to result in a faster reaction rate. Why? Because the particles are moving faster as a result of increased temperature. Remember, temperature measures kinetic energy. So if we increase the temperature, particles are going to be moving faster, resulting in more effective collisions, resulting in a faster rate of reaction. So let's try this problem. A reaction is most likely to occur when the colliding particles have proper orientation and remember, the two requirements for reactions to occur is that the colliding particles have the proper orientation and the right amount of energy. Thus, choice 4 is the correct answer. As the temperature of a reaction increases, it is expected that the reacting particles collide Remember, temperature measures kinetic energy, so as temperature increases, the particle movement increases. As particles are moving faster, they're going to collide more often with greater force. As a result, the reaction rate is going to increase. Next problem, as the temperature of a chemical reaction in the gas phase is increased, the rate of reaction increases because since temperature measures kinetic energy, if we increase it, the number of collisions are going to increase, which causes the reaction rate to occur faster. Therefore, answer choice 2 is correct. So remember, when it comes to chemical reactions, increasing temperature is going to increase the rate of reaction because the number of colliding particles is going to increase. Without the right amount of energy, that reaction is never going to take place. And we can always tie this back to collision theory. Anything that increases the number of collisions is going to result in a faster rate of reaction. Way 74, faster reaction rates occur when we increase the concentration. Think about this. If we have a container filled with very few particles, the number of collisions is going to be very few because they're not going to interact and collide with one another as often as if we increase the number of particles. Increasing the number of particles is the same as increasing the concentration. Whenever we increase the concentration, more particles are going to collide. As a result, the rate of reaction is going to increase. Consider this problem. We have a balanced equation representing the following reaction. Which change in reaction conditions will increase the frequency of effective collisions between reactant molecules? Remember, reactants refer to the species to the left side of the arrow, and products are all the species on the right side of the arrow. So what can we do to the reactants to increase the frequency of effective collisions? We'll use this idea and consider what the correct answer is. In order for the species to effectively collide with one another, one way we can increase the reaction rate is by increasing the concentration of reactants. If there are more reacting particles, there are going to be more collisions, and these effective collisions are going to result in an increase production of products. Stamping an identification number into the steel frame of a bicycle compresses the crystal structure of the metal. If the number is filed off, there are scientific ways to reveal the scratched off number. One method is to apply aqueous copper 2 chloride to the number area. The copper ions react with some iron atoms in the steel frame, producing copper atoms that show the pattern of the number. The ionic equation below represents the reaction. Another method is to apply hydrochloric acid to the number area. The acid reacts with the iron, producing bubbles of hydrogen gas. The bubbles form faster where the metal was compressed, so the number becomes visible. The equation below represents this reaction. Describe one change in the hydrochloric acid aqueous that will increase the rate of hydrogen bubbles produced when the acid is applied to the steel frame. So how can we increase the level of hydrogen bubbles using this idea and this equation? Well, in order to produce the hydrogen bubbles, what two species must react? The iron and the HCl have to react. Given that we can't increase the number of iron particles, what we can do is increase the concentration of acid. Doing so will cause the reacting species to collide more often, resulting in an increased production of product. Alternatively, one thing we could do is increase the temperature at which this reaction occurs. Remember, if we increase temperature, we're going to increase the kinetic energy and cause more collisions to occur. Way number 75. Another way we can increase the reaction rate is by increasing the surface area. Consider two dissolving species, one powder and one whole. The powder is going to dissolve faster because the powder has more exposure to the water in which it's being dissolved. Look at this species. We have a green cube being dissolved in water, and only the outside particles get to make contact with the water. Once those particles react, then it reveals the smaller cube inside. But if we were to split up the crystals into smaller species, then more of the green particles are exposed to the water. As a result, the species will dissolve faster because there's more surface area. So, increasing the surface area is another way we can increase the rate of reaction. A 5-gram sample of iron solid is to be placed in 100 milliliters of hydrochloric acid. Which changes will result in the fastest rate of reaction? So notice that the answer choices are both modifying the surface area and deal with concentration. So which one of these answer choices will result in the fastest rate of reaction? When it comes to modifying these factors, tie it back to collision theory. How do we increase the exposure of iron to hydrochloric acid? Well, we increase the surface area. What else can we do? We increase the concentration of HCl. If there's more HCl particles, then that means that there's going to be more collisions between the iron and the hydrochloric acid. So the correct answer is 1. Last way to increase the reaction rate is by adding a catalyst. A catalyst increases the reaction rate by lowering the activation energy. If you recall, every single species has to react at a starting energy and a final energy. When a reaction proceeds, it has to get activated at this peak point. This is called the activation energy, and it's the amount of energy it takes to break those bonds and reform new ones. But whenever we add a catalyst, it lowers this hill. It lowers the amount of energy it takes to activate the reactants. Compared to the uncatalyzed pathway, the hill is a lot lower, so it takes less energy to activate the reacting particles. As a result, the reactants can proceed through products in a faster way. So, how do catalysts increase reaction rate? They lower activation